Can I share my screen on a YouTube live stream? Yes. Oh, nice. Can I pause a live stream? One, two, check. Uh-oh, what happened? Oh, yeah, okay. Canvas is really slow today. What is this? No, the word's not as bad. Just goodness.
Hello. Oh, hey, man. Jeez. So difficult deciding a seat, isn't it?
Yeah. I just mostly sit somewhere where I just feel comfortable with.
Have to what? Don't have to what?
Oh no, I just said I normally sit somewhere where I just feel comfortable at.
Oh,
Anywhere near either from the back or the front. Doesn't really matter.
I'm trying to figure out what's that seat for me.
It's just that one arm. Ooh. So rigid, isn't it? I love these arms, so weird.
Hello.
Morning. Canvas is slow. Morning. Oh my God, Canvas. What time is it? It's 2:53. All right, nerds, let's learn how to program a computer. Let's go. I'm going to go ahead and get started. I'm not going to take attendance until a couple more people roll in here. People are late on the first day. My name is Dr. Morgan. I will be teaching computer science for, what's the official name? Computer science for computer scientists and engineers. This is a programming course, not a course about what's a computer and how do you use a computer. This is a course about writing programs. I have not taught this course since 2017. When I taught this course in 2017, it was the same course in a different language. We taught it in C++ and Java back then. Now we teach it in Python. The reason for that is Python is quickly becoming a more popular first language for programming. I have mixed feelings about that. There are things I absolutely love about Python. There are things I absolutely hate about Python. Some of the things I hate about Python are because I've been programming since I was 14, which was 40 years ago, and I've gone through a bunch of languages, and you learn to like certain things about some languages and dislike things about other languages. I'll try not to complain all the time about the things I don't like about Python, but I probably won't be able to do that. I actually teach I mostly teach physics and astronomy here. My PhD was in physics. I've been teaching physics and astronomy this is basically my 25th year of doing that. But we've only really got one full-time computer science professor here. He teaches the class that's for non-majors, basically just computer architecture and how computers work and what's the difference between RAM and a hard drive and all that business. For the past couple of years, this class has actually been taught by an adjunct, completely online. I don't think a completely online class is the best way to learn programming. I think the best way to learn programming is in a lab like this with somebody to look over your shoulder and help you out when you've got problems. So we'll talk about the way that our Tuesday labs are going to work. So I decided, since I'm a little short on classes this semester, to take this class over. I really like teaching programming. I really like programming. I really like the task of sitting down and writing code and debugging code. Hopefully some of you, maybe not all of you, but some of you will realize that that is something you enjoy doing, that there's a zone that one gets in when one is programming and coding that it's one of the, I can count on one hand the number of activities that I get into that zone, and coding is one of them. So I really enjoy doing it. And the way I teach it is mostly to do it. I'll come up here, I'll give a couple of examples, we'll do some sample code, and we'll put a problem up on the board and you will watch me solve that problem in code in real time. Some of you will really like that way of teaching. Some of you might not like that way of teaching. Kind of watching someone go through the thought process of writing code, I think is really, really, really instructive. I'll make mistakes, but making mistakes is part of coding. I'll forget the syntax for some Python statement, but forgetting the syntax is part of coding. And so you get to experience all these things in real time before getting a chance to do it yourself, as we learn these different things. Why am I teaching computer programming if I'm not a computer programmer? Because most scientists who aren't experimental scientists, who don't, well, let me qualify that, most physical scientists, physics, astronomy, geology, chemistry, who aren't doing experiments are doing theory. Most of what doing theory is nowadays is spending a couple of months coming up with some equations and then spending a couple years writing a computer program to execute those equations. My PhD thesis was in theoretical particle physics. It was 3 months of writing an equation, which filled out, what was the final page count? Written out by hand, it was about 60 pages of a single equation. And then the next 3 years was taking that equation and writing computer code to calculate that thing that we had just calculated. So most of my research as a physicist was writing computer programs. I was writing those on a Macintosh Plus, those little tiny 9-inch little gray box Macintoshes from back in the 80s. Even though it was already the 90s, the professors had all the good computers and the grad students had the crappy old little Macs. I wrote those programs in C. So I started programming when I was a teenager in BASIC on a Commodore 128. When I was in high school, I learned Pascal on an Apple IIe. In college, I was programming in C. In grad school, I was programming in C++. My professors were all 60-year-old physicists, so they all programmed in Fortran, which is a language from like the 60s and 70s. So I had to learn Fortran to understand what my professors were programming so I could translate their programs into C++. When I started teaching programming at the high school level, teaching robotics classes and stuff, we used Java. Java is still a really popular language. In fact, if you take the second course in the sequence, this is Computer Science 221, Computer Science 222 is all the same stuff, but in Java, and learning the object-oriented programming that comes along with that. So I learned Java to do that. I taught 222 in Java, like I said, back in 2017, 2018. And then a few years ago, I decided to pick up Python and learn that language. Like I said, it's a powerful language. It's an easy language in a lot of ways. And but my Python is not as good as my C++ or probably my Java. So every once in a while, I'll accidentally type the C++ syntax for something. And it's your guys' job to pay attention all the time while I'm typing and say, hey, Dr. Morgan, that should be a colon instead of a semicolon. Hey, that should be an elif instead of an else if, because I use the wrong syntax. So you can help keep me honest, keep my Python good. So that's a little bit about me and why I'm teaching this class. This is the landing page you will see when you go to Canvas. There's a couple of links to some important resources. One is to the textbook. The textbook we are using is linked right here on your homepage. It is the textbook from OpenStax. Raise your hand if you used an OpenStax textbook before. A lot of professors are starting to move towards them. They are free. They are online. If you want to pay them $47 and order a printed copy, you can. If you really like printed books, I think ordering a printed computer science book is fairly crazy, so I'm not going to do that. But if you go to, Canvas links right to it, but if you just go to OpenStax, go to subjects, go to computer science, go to Python programming, that's the textbook, click view online. You can give them some money if you're feeling generous over not having to buy a $100 textbook for this class, but you can just click go to your book and view it all online. The book is mostly there as a resource for you. Every once in a while, I'll say, read chapter 3.1 tonight as a review of what we did in class today. But you're not going to have homework assignments from the book. You're not going to have a whole lot of reading assignments. One really cool thing about the book, however, is because it's a computer science book, it has little video tutorials in it, which is nice. They're actually just links to YouTube videos, but it also has, let me see if I can find one in this chapter. Yeah, it has little places where there's a little problem and you can stop and you can write some code in a little box in the textbook and it will check that code for you. So it has little exercises, little practice exercises for you. A great way to practice when it's time to study for an exam. It's a really nice feature that is really surprising to me that they can do that for free. I know there's a textbook company called ZyBooks that I used during COVID. I was teaching the Java class when COVID hit a few years ago, and I had to go completely online at the end of the semester. And I found this company called ZyBooks, which is a similar kind of deal. It's like an interactive textbook, but they're like $70, $80. This is 100% free, and it's got all these cool features. So, like I said, you can write your code in the little box here, and you can hit run, and it will tell you if your code was right. Again, we're not going to use it a lot, but it's a nice resource to have. If you like books, I think it's also nice just to have a reference book to go to when you can't remember the syntax or something, or you want to see some more examples of something. There's a good series called the Head First series, Head First Java, Head First Python. Head First Python is pretty good. I just bought the Python for Dummies book just so I can have it around when I want to look up the syntax or how a dictionary works. I can just look it up in the Python for Dummies book. I also have, oh, I didn't bring it with me. I've also got one of those laminated folded cheat sheets for Python. It's like all the commands that you might need to use, and it shows examples of the syntax. I haven't figured out for exams what I'm going to let you bring. I'll talk about this when we talk about academic honesty and stuff in the syllabus. In my physics classes, I let my students bring one sheet of paper with any equations they want written on it, so they don't have to memorize a bunch of equations. The secret when it comes to teaching programming for me is I don't really care if you remember syntax of stuff. Syntax is easy to look up. It's easy to look up. Does this have square brackets around it or parentheses around it? I don't remember. Look it up. I don't care. The reason I don't care is because just like I gave you a list of 5 different programming languages I've known and worked in my life, if you're going to program computers either for a living or as a tool that you need for your toolbox in your job, you will also, by the time you're 50, program in 4 or 5 different languages. I don't really care about syntax because the syntax will be different 2 years from now when you're programming in Python++ or whatever. So I'm going to let you bring something to quizzes and exams. I'm just not sure what. It might be 1 sheet of paper with anything you want written on it. It might be 3 sheets of paper with anything you want written on it. It might be anything made of paper that isn't the internet. Bring a whole Python book with you. I don't really care. So I'm figuring that out. And we'll talk about that before we have our first quiz or test or whatever. Let's go back to the homepage. Is there anything else on the homepage that we need? Oh, yeah, we'll come back and talk about the IDE we're going to use. I've got a link to a bunch of videos. It's a video playlist on YouTube. It's from the Crash Course series. Crash Course makes really good introductory and review and study videos for all sorts of different subjects. They've got them for Python programming. I've also got a link to the official Python documentation and reference here. If you're really getting into the nitty-gritty of some command and you need to really, really know how it works, that's a good place to find the official from the people who program the language itself, the official breakdown of the language. That's usually more information than you want. And we'll see as we go along how to get the level of information you want when you are coding. So here's the syllabus. You'll find it. Actually, let me find the actual document. Syllabus is on Canvas. It's linked from Canvas. This is all the stuff you need to know about me. My office is in 123, which when you come in the main door of McNear, there's a little hallway off to your left. That's where all the faculty offices are on the first floor. There's another, if you go up to the second floor, there's another hallway in the same place, or if you're taking biology or chemistry, that's where your professor's offices are. My office is 123. My phone number is on there. Don't call that. I don't pick up the phone in my office. At best, you will leave a voicemail and it will email that voicemail to me. Just send me an email. It's way easier to do that. I'm usually on email. I will usually respond to emails during the semester up until usually about 1 a.m. is usually when I close the computer and stop interacting with people. On the weekends, it's a little bit later. So email me anytime. You usually get a response fairly quickly if you have any issues. Open student office hours for you to come and ask questions are Wednesdays at 10, Thursdays at 11, Fridays at 12, and any other time I'm in my office. I'm usually in my office before 11, like from 9 to 11 every day, Monday through Thursday, but I've got 11 o'clock class, so usually I'm prepping for the class, so I won't always be free. But if you've got a quick question, swing by any time in the morning. Our labs on Tuesday are fairly open times, so if you've got questions, you can ask those questions during lab when you're working on other stuff. We'll talk about that. So the format of the class: 2-hour lecture, 2-hour lab. Most of our science and upper level math classes are 4 credits. This is 4 credits. Instead of meeting 4 days a week for an hour, we've got these 2-hour and 50-minute lectures on Monday and Wednesday. And then our Tuesday lab goes, I think, officially 12:30 to 3:20. We won't always use all that time, but we use a lot of that time. Most Mondays and Wednesdays, I'll introduce a topic. I'll show some examples. You code by yourself for 15 minutes. We'll be done for the day. Tuesdays, I'll show some examples, maybe introduce a new concept. But most of what we'll do on Tuesdays is you will write programs based on the stuff we learned on Wednesday and Monday. Things that may take a little more time. Things that I can come around and help you with while you write code. The other thing we'll do a lot on Tuesdays is little quizzes. Here's a little code problem for you to solve before you leave today. And that's also when we've got an exam, we'll have an exam during that Tuesday. So lots of stuff going on those Tuesdays. Again, it won't always be, we're clocked in here all the way till 3:20. A lot of times it will be, here's a programming task, and here's a little quiz. When you're done with them both, you can go. We might be done by 2 o'clock, a day like that. Okay, so it'll be different every week. But we want to make good use of that time. We want to use as much of that time as we can because it is a 4-credit class. Prerequisites. I want to talk really, really briefly about this, and this is not to scare anybody away, but this is just thinking about what a programming class is like. The math prerequisite for this class is just Math 121, which is Pre-Calc 1. Computer programming is a mathematical subject, but it's a mathematical subject in a way that maybe you haven't encountered before. You won't be manipulating equations. You won't be doing much math because the computer does the math for you. What you'll be doing is thinking about problems in a quantitative way. In other words, you'll be thinking about physical systems and thinking about, how do I represent that physical system as a bunch of numbers? What are the variables I need? What are the values for those variables? What you'll be doing is thinking about solving a problem and breaking that program down into an algorithm, into a set of instructions, which is essentially a mathematical process. So while this class doesn't require you to know a bunch of math more complicated than what's a prime number, it does require you to sort of be able to think mathematically. So the more math you have under your belt, the better. If you are in Math 151 now and plan to take calculus in a year, maybe you want to put this class off until you're in calculus, because by then you'll have a little more mathematical tools under your belt to bring to the problem. It's not a big deal. And like I said, I'm not, in my physics class, I caution people, if you do not have enough math, you will fail this physics class. Like, there's no question about it. This is not like that. It's a question of if you feel like you need a little more experience taking a few more math classes, getting comfortable with quantitative thinking, thinking about numbers, thinking about problems in terms of numbers. Putting a class like this off until after you've taken 151 might not be a bad idea. That's not a make or break the way it is in physics. These are the learning outcomes. I'm not going to read these one by one, but this is what this class is about. Devising algorithms to solve problems, learning the syntax of a programming language, in this case, Python, analyzing code and diagnosing, debugging common programming errors. When you write a program, I would say 25% of your time is programming, and then 75% of your time is debugging the thing you just programmed, because there's a whole bunch of mistakes in it. And that goes for every level of programmer, whether you're a beginning programmer or somebody who's been programming for years. Creating solutions to problems by developing applications, and using good version control and commenting, and writing code that is readable, both by you and by anyone after you who might encounter your program. We'll talk a lot about that. Notice nothing in these learning outcomes says Python in it, and that's on purpose. That's so if we decide in 2 years to change this code, this class, from a Python class to a Scratch class, or to a Java class or a JavaScript class, none of these learning outcomes would change. You're still learning how to write programs, debug code, think about problems in terms of algorithms. This was intentionally written to be language agnostic. So I could teach this class in C, I could teach it in Java, I could teach it in Python. The content really wouldn't change. All that would change is the computer language in which I'm programming the content. Required text, already talked about that. OpenStax. Recommended computer resources. In class, we'll be using a computer. You need to have access to a computer outside of class to write your code, to do your homework, to do your assignments. The kind of computer does not matter. You should not have to install anything on the computer at all. If your main device is an iPad, probably going to be tricky to write code on your iPad, but maybe it'll work. I don't know. But your best bet is to have some kind of computer with a web browser, and you'll be able to access everything you need for the course. The IDE, Integrated Development Environment, we are using for this class is called CodeHS. So all of the programming we will be doing is in a browser window. You don't have to install anything. You don't have to go anywhere but to the website. And that's where we will write all of our code. So that makes it easy to, any code you write here in class, if you save it in CodeHS and open your CodeHS account anywhere, that code will be there for you to see. So that's, I think, an easier way to do it. What are we going to be doing in the class? There's going to be a lot of programming assignments. There's going to be a few readings and written assignments, weekly in-class activities on Tuesdays, and some programming quizzes on Tuesdays, and then a final exam. The final exam will be comprehensive. It will cover everything we did over the whole semester, but it has to, because that's the way programming is. You learn the syntax for all the things you need to do, and so that's unavoidable in a programming class. This is the breakdown of how much your grade is worth. Most of your grade is the programming exercises. A little less for exams, a little less for homework, and then attendance. I will take attendance every day. I'll take attendance for today in a little bit. That should add up to 100% if I did my math right. Yeah. Pretty straightforward. Late work. If you hand in something late, I dock it by a letter grade. If it is more than, you can't get a grade of higher than 80% on a late assignment. If it's more than 2 weeks late, it's 50% maximum grade. That's still better than the 0, by the way. Zeros will wreck your average, just mathematically. In fact, the way that grades work doesn't really make any sense. The 90, 80, 70, 60, 50, 0 is crazy, and it doesn't really give a fair account of your average if you don't turn in a bunch of assignments. So turn in something, turn in late. Get a 30 instead of the 0. It will save your average, trust me. No late assignments will be accepted after I have graded everyone else's assignments and posted solutions to them. It's usually when you have a programming problem. I will post the solution to that. I won't obviously take any submissions for an assignment after I posted a solution to the assignment, just copy my solution. If you're gonna be absent or miss class on a day when we're having a quiz, let me know ahead of time if you can. I will only make up exams if there are extraordinary circumstances. And those makeup exams will usually be different from what I gave in class and often more difficult than what I gave in class because of the extra time to prepare. This page of the syllabus is really, really important. I'm not going to read it and go through all of it now, but you should read it on your own. You should read it before your first programming assignment is due, and you should take a peek of it at it every time you have a programming assignment. This is what I will be grading all of your programs on their functionality. Do they work? Their efficiency? Are they coded in a way that makes sense and does the job with the fewest number of lines of code and the fewest number of awkward lines of code? And the format and style. Can I look at your program and read it and tell what it does? Do the variable names make sense? Is it commented? And we'll talk about what commenting is today. Okay. Is it organized and easy to follow? So everything you code in this class, I will look at this rubric and give you a certain number of points for the functionality, a certain number of points for the efficiency, a certain number of points for the format. This is just official RBC stuff. These few pages are the same in all the syllabi you get from all your professors. So withdrawal policy, last day for withdrawal is 31st, I think. We'll see that when we scroll down. The official attendance policy, this is a 4-credit class, which means if you miss 4 classes, I can just fail you. I don't usually do that. Students who miss a lot of classes usually just fail the class themselves. I don't have to do that manually. In my physics class, I say the only way to pass this class is to come to this class and to listen to me lecture and to watch me solve problems. You're not going to be able to pass it on your own. Is that true of this class? Could you go somewhere else and watch somebody else's programming videos and not come to class and pass it on your own? Maybe. I don't know. But there are some official policies that I am bound to follow. One is that attendance counts for like 10% of your, was it 10%? 10% of your grade? Yeah, so if you're absent a bunch, that will reduce your attendance grade. But the other is if I do not see you for 2 whole weeks, 14 consecutive calendar days, you will just be dropped from the class automatically. That will happen in all your classes. It's an official RBC policy. It has to do with things like financial aid. The government can't be giving financial aid to students who aren't really going to school. So if you just disappear, you'll be dropped from the class. You can ask, hey, I was in the hospital and didn't get a chance to give you the note, or I had some kind of extenuating circumstances. You can ask to be let back in. That's an easy process to get you back in, but that happens automatically. If I mark you absent in my roster for 2 whole weeks, the registrar just takes you out of class. Come to class. That's the best way to learn. Academic honesty. This is a really tough one for this class in particular. The first part of this will be the same in all your syllabi. Read the student handbook, know what academic honesty means. Obviously, the most important thing is to not copy work from some other student and hand it in as your own. That has happened to me in this class. I was actually just backing up an old hard drive the other day and found 2 documents that were just screenshots of 2 students' programs that were exactly the same variable names, exact same comments, exactly the same code. Easy for me to spot. Do not do that. Okay, that should go without saying. The other thing you can do, though, is go online and find somebody else's code who solved a similar problem and find their code and paste it in. I caught people doing that also. The way I usually catch people doing that is they don't realize that they're using some advanced programming technique that we have not covered yet, and I don't even know what's going on. So if you post something as a solution to an assignment and it uses some methodology that I don't understand, I'm going to take a piece of that, I'm going to type it into Google, and I'm going to see if I can find where you stole it from. I've done that before in this class in the past. Don't do that. But if you do that, just cite it. Just put a comment in the code saying, this is based on an algorithm I copied from Stack Overflow. Here's the URL. That's fine. Programmers copy code from other programmers all the time. When I'm writing code, the first thing I do is think, have I written code like this before? Let me go back and find an old program of mine and copy that code and paste it in.
If we cite a code in an assignment,
Yep.
and we use a URL,
Yep.
do we deduct points for that?
No. The only reason I would deduct points is if you just wholesale lifted the whole code from somewhere. But if you needed an example of a function that found a bunch of prime numbers and put them in an array or a list, and you found that code, and you wrote your own code based on that, and you changed the variable names, go for it. All I care about is you know how to adapt that code to your program, and that you're honest about the fact that you looked up that somewhere. Now, if you're confused about some syntax and can't remember if a print statement has square brackets or round brackets, you don't have to cite that. You just look that up and find that. I'm talking about copying lines of code that do something, right? Just cite it. It's easy. There is something else now that we have to worry about in the world, though, that did not exist when I taught this class in 2017. Anybody have any guesses what it is? Yeah. AI. So, when I went to start planning this class, when I decided I'm going to teach programming again, I'm going to choose an IDE. IDE stands for Integrated Development Environment. It's where you write your code. In 2017, the IDE that I used was a website called Replit, REPL.IT. Really good online IDE. I was going to use it again. I went, opened up Replit, found that they changed the policies for how many students can be on a free account, that kind of stuff. But I started writing the code, and I found that Replit, I would type half the line, and Replit just finishes all the code for me. It figures out not only what I'm trying to do, but it then does it itself. Well, that's not, I mean, that's great if you're writing code for a living to have an IDE that guesses what you're trying to do and then does it for you. It's not good if you're trying to learn how to code, and I need to know if you know how to code. I was, one of the things I do for myself when I'm learning a new language is I create a program that's got an example of the syntax of every single command in it. Variable assignments, math stuff, for loops, while loops, if then statements, just all the things. I just do one example of each and I keep it one piece of code so I can go copy that. I was writing code for mathematical operators. Here's how you use the plus, here's how you use the division, here's how you use the modulo operator. And I went to create a new line, and the IDE guessed what the next thing I was going to teach was. Which is crazy to me. It makes me think that maybe there's just nothing running inside my own head but a computer program. But the computer can guess what I was going to do next. So I switched from Replit to CodeHS. CodeHS is a fine IDE, but it does not have built-in AI code completion. Like I said, when someone's paying you to write computer programs, use that stuff all you want. When you are trying to demonstrate to me that you know how to write code, that's not going to fly. So the generative AI policy for this class is very simple. If I have compelling evidence that you used AI tools to complete an assignment, you will receive a grade of F for the course, not for the assignment, for the whole class. End of story. You can have a great appeal in an academic standards hearing if you want. Those usually go in favor of the professor. I will tell you from having done many of those. How will I know if you've done that? Because every time I give an assignment, I will type it into ChatGPT and Replit and receive the code that the program writes. And if your variables are the same as the code that ChatGPT and Replit come up with, well, that is compelling evidence that maybe you used AI to complete that code. The other thing is, and this happened with me in the past with students who have copied code from other places, it's very easy for me to adjudicate that, which is I print out your code, I put it on a piece of paper, we sit in my office and say, all right, explain how it works. Explain the code, explain what all the variables do, explain the syntax. If you wrote the code, you can do that. If you did not write the code, you cannot do that. So that's a very easy thing for me to figure out. Hopefully it's not an issue. I'm not saying this to scare anybody or to be to make it seem like I assume that people are going to do that, because I really want to assume that people aren't going to do that. But I'm also have been doing this for 25 years and know that you got to keep an eye out for this stuff because it happens. Student support services, again, this will be the same in all of your syllabi. Student success, learning mentors, counseling services, disability services. If you have an accommodations letter, make sure I get that soon. Tutoring, there's really nobody around tutoring computer science that I know of. The tutoring center is this end of the hallway, the big room. It's usually math and science professors in there. I'm probably going to do one of my office hours in there every week, probably on Fridays is where I'll have my office hour. So the best source of information is for me, but there is a tutoring center. I will talk to Ben and see if there's anybody, any of the tutors took this class last year. Library student handbook, all that business is the same. Here's the important dates. August 30th is the last day to drop. November 1st is the last day to withdraw if you're not doing well and want a W instead of an F. You can do that all the way to November 1st. And then this is a schedule. Don't take the schedule too seriously. I'll fall behind. Actually, at the beginning, I'll probably get ahead of the schedule a little bit. We've got Labor Day off. And somewhere around here, we might start to fall behind. But it just gives you a general idea of what we plan to do. You'll notice that after the first few weeks, the Tuesday lab is just set aside for project work. So a lot of the stuff we do during that day will just be in-class programming. Exam 1, Exam 2, and Exam 3. Again, these dates are tentative, but I'm going to try to stick to the schedule. So by the end of September, we'll have our first exam. The other thing I'm going to do to fight against ChatGPT is give you a lot of in-class assignments that are just on paper. Here is some code, find the mistakes on it, circle them with a pencil. Things that you can't do with your computer, you can do with your computer off. And that's the end of the syllabus. Any question about course policy type stuff, what the course is going to be like, what we're going to cover, what we're going to be doing day to day? Yeah.
When we do our exams, are they going to be like question based, like ABC, or is it going to be more so like do this program,
It's going to be
find this error?
half and half.
Okay.
There's going to be some, on paper questions. What will the output of this loop be? Just write it down in pencil, right? Here's a piece of code that's supposed to do such and such. Will it work? Okay. If not, fix it, right? Those sorts of things. And then there will be a programming task or two, right? Write a piece of code that open up CodeHS, write a piece of code that does this.
In CodeHS, I'm gonna use Python 3 or another one.
We use Python 3 for almost everything. And I'll go through that in just a minute and show you kind of what to do in CodeHS. One of the things I haven't figured out, and I need to play with CodeHS for a week before I figure out the best way to do this, is how I'm going to have you guys submit your assignments. There's a few different ways to do it. One is to have you submit it right in CodeHS. One is to have you do your work in CodeHS and just send me the link to your code in Canvas. And the other is for me to just set up a Canvas assignment for you to write your code in CodeHS and just copy and paste it, all your code into the Canvas assignment. I think number 2 is the way I want to do it, because I don't really have a grade book in CodeHS because I just got the free version. So I think you'll write your code in CodeHS. There's a share button. You click the share button, you copy the link, you just paste that in the Canvas, and then I can just pop. So probably. If that doesn't work after a couple of weeks, maybe I'll change the way. Because it's a new tool, I want to figure out the way that works best for me and the way that works best for you, and those might not be the same thing. So here's CodeHS. Actually, before I go on to the next step, let me take attendance, because we are at least one person short, because there's one person who I know. I'm working with 2 computers here. So let's see. Attendance. We're missing a bunch of people. Thiago Winters. Peter Barnett.
Sorry, I gave you, I had it.
Thanks. Blair is not here. I know Blair. Isaiah Bolden. Here. Lauren Bowman. Jordan Brown. Here. I didn't even see the top half. I never learned it by his name, but I can see from here. Marcus Brown. Ryan Church. Ryan. Brenton. Is it Figures or Figuras Mormon? Or is there no Brenton at all? Brenton. Going once, going twice. Brenton. Vincent Gardner. Shanice Morris. Miles. Did you take my astronomy class like 100 years ago?
Yep.
Yeah. Good to see you again. Douglas Robinson. Parker Twyford. Logan Vivieros in the back. Isaiah Williams. Isaiah?
Yeah.
Thank you. All right. Anybody who's here I didn't call. All right. So this is our, let's go back to, I don't know what you see. So this is what I see when I log into CodeHS. You'll see something slightly different because you are the student and I'm the teacher. I see 4 people have already registered. The thing that is most important to you is the sandbox. The sandbox is where you actually write your code. So I'm going to click on the sandbox and just get a little peek at what our IDE looks like here. The first thing you'll get is a prompt to create a new program. Down here, you'll have all the programs that you have ever written for the course. This list will get pretty long by the time the semester is over. So come up with a good naming scheme for your code. Give them names that mean something, not example 1, example 2, example 3, or you won't be able to figure out what code is what. I'm going to give my program a name, day 1, hello world. And then click create program. And then it gives you a bunch of choices. What would you like me to create a program in? CodeHS knows a lot of different languages. It knows Java, it knows JavaScript, it knows Python and a bunch of weird other versions of Python. It knows HTML, it knows C++, it knows SQL. We're going to be using Python 3 for everything for the time being. So you tell it you want to create a Python 3 program, and then you click on, oh, it knows other processing, regular old C with no plus, it knows Scratch, it knows all kinds of things. But we're going to click Python 3 and then create program. And then it will create a program. And it puts a little code in there for you. And the code that it puts there for you is print hello world. This is a standing thing in computer science that the first thing you do when you learn a language is you tell that program to print the words hello world. It goes back to the very first programming language that can communicate with a console. So it always fills that in for you. There are 3 columns here in your IDE. This is where you write your code. This is the console where you see the output of your code. And this left column is where you have all the files that your code uses. For most of the semester, we will just be using one file. That is the file that Python always names main.py, main.python. That's where your code is. But if we're using some external functions that live in another file, they would be in that column. If we're using a big data file, like suppose I wanted to read all the names of the students in the class into the program from the data file, I can put that data file over here and it could import names from that. I'm not doing any of that. We won't be doing any of that for a while. So most of the time in class, you will see me grab, the first thing I do when I open the IDE is grab that sidebar and just close that up. I don't need it. I don't need this. There's only one file over there. I don't need to see it. Anytime I need to open it back up again, I can grab it and open it back up again. Okay, but I'm going to hide it. And then I make this pretty wide and my output window pretty narrow, so I have lots of room to write my code. you'll see sometimes it's talking to you over here. It creates an individual server on the CodeHS server for you to execute the code. You don't have to worry about any of that until you tell it to do something. The way you tell it to do something is by clicking run. And since it actually wrote some code for us in the window, we can click run and it will do something. And what it will do is print hello world. Why? Because all the program we wrote in our Windows says to do is print hello world. Okay? That is called a statement. A statement is something that the computer executes. If I want to change it, I can change that to hello class. Click run. And it prints hello class. If I want to create another one, I can copy and paste it. Copy. Paste. Welcome to CSCI 221. Run. Okay, so that's the simplest thing you can do in most languages is just print some text to the console. Okay, this is called a console. It's a virtual console. Back in the days when you were programming on a little green light CRT screen, it was a physical console that your output was on. Some weird things about Python to talk about up front. One, Python accepts for a print statement both single and double quotes. None of the languages I know, C, Pascal, Java, will accept that. That's nice because you don't have to remember you're supposed to type single quotes, double quotes. Can you mix them? I bet you can't mix them though. I bet if you made one double and the other one single, it would complain about that. Aha! So now you get to see the other important thing that shows up in the console, which is an error message. If anything in your code is incorrect, and by incorrect, I don't mean the program doesn't do what it's supposed to. That's your problem. If the syntax is incorrect, if the actual things you have typed does not make sense to the Python interpreter, you will get an error. And it says, syntax error, unterminated string literal detected at line 2. There's something good in there and something bad in there. What's good in there is it tells you where the error is. There's something going wrong in line 2 of the program. What's bad in there is you might not have any idea what unterminated string literal means. In fact, I would say more than half the time, I have no idea what the error message is telling me. It's just telling me something is messed up here. You got to go fix it. What did I do? I used the wrong kind of thing to close my string. What's a string? A string is a bunch of letters that make a word, right? So in this example, hello class is a string. Welcome to CSCI 221 is a string. And by not putting that right kind of quote at the end, I didn't terminate it. I didn't end the string properly. That's what unterminated string literal means. Like I said, most of the time we will have no idea what it's talking about. Suppose I took those out entirely. Print welcome to CSCI 221. Run. Takes a second. It's got to create a server. Ooh, why is it taking so long? Every computer science professor in the world is trying to do this right now. Syntax error, invalid syntax. Perhaps you forgot a comma. It tries to help, but usually its help is not helpful. That's not what I did. What I did was I forgot to put little quotation marks around my string there inside a print statement. What it's trying to do is interpret the words welcome and CSCI as words in the Python language, and those are not words in the Python language. What we learned just from this little exercise is how unforgiving programming is when it comes to syntax. You can't have a quote where you shouldn't have a quote. You can't miss a quote when you're supposed to have a quote. Okay? If it is not written in the exact correct programming syntax, you will get an error message. Okay? So let's fix that. I don't know. I actually like, even though the single quotes are nice because you don't have to hit the shift bar, because I've been programming for 25 years, I will almost always use the double quotes just because that's what's in my head. That's a quote. A quote is. What if we did something like this? Print 2. Without the quotes. Think we'll get a syntax error? No, we don't get a syntax error. Why? Because 2 is a number and computers understand numbers. When we print the number 2, it understands that we mean the number 2. Suppose we said print 2 plus 2. Oops. What do we think it'll print? You think it'll print 4? You think it'll print, how many people think it'll print 2 plus 2? 2 plus 2. How many people think it'll print 4? How many people think it'll print a 2 and another 2? Let's think. 4. So Python understands that this 2 plus 2 is a single mathematical expression, and it evaluates it for you. That's interesting. What if we did this? Print 2 plus 2. Now do we think it'll print? 2 plus 2, right? Now it reads that as a string. I'm telling it by putting quotes around it, I want you to print what's in the quotes. Don't interpret it. Don't read it as a number. If I put quotes around it, just print that thing. That's an important thing to learn too. The difference between a string, which is a set of characters in quotations, and a mathematical expression, which is something that computers understand how to evaluate. Now, each of those are statements. That's 4 statements in Python, 4 print statements in Python. One of the things that we also want to be able to do in and around our statements is to explain to ourselves or to anyone reading the code what is going on. And the way we do that is with what's called a comment. Every programming language has comments. Every programming language has a different syntax for a comment. Notice, nothing changed about what the program did. Notice, as soon as I put the little hashtag symbol in there, the text changes to green. That's something that the IDE does for you to help you see which things in your code are executable statements that the Python interpreter is reading, and which things in your code are comments. The comments are there for you. The comments are there for me, who's reading your code, or whoever reads your code. And you want to use a comment every time anything in your code requires some explanation to understand what's going on. The way you do a comment in Python is with a hashtag, and as soon as you hit return, it will understand that as the end of the comment. So I could comment every one of these lines if I wanted to. I'm going to do it like this and make it really, really bad.
Do you want us to comment on everything, even if you understand it?
We'll talk about that. So reads this as a math expression. Python reads this as a string. Also, see, Python reads this as a string and prints it. Okay, so if I hit run, nothing over there in the console should change, unless I made a mistake. Nope, everything's the same. Okay. So I have commented every line of this code. But instead of making the code easier to read, it kind of makes the code harder to read. Because it's kind of hard for your eyeball to separate the statements from the comments. This is when we get to style. Just like everybody's got different handwriting, Just like everybody's got a different style when they play a musical instrument, everybody's got a different style when they code. There are some good practices and bad practices though. I think it's a good practice to always have your comments aligned. And this is where we learn something else important about Python, is that Python doesn't care about your spaces. So whichever your longest line of code is, align all your comments. Like so. And suddenly, oh, I love the way that looks, right? Now you've got one column with your code in it and one column with your comments in it. And you can look at that and kind of tune out the comments until you need them. I like that a lot. I actually like my comments to be a little bolder. So when I comment in Python, I usually use 3 of these. Python doesn't care. The first one tells Python it's a comment. The other 2 don't tell us anything. Those other 2 are there for me. Okay? They're there for me to see my comments, to make them jump out of the code at me. Notice nothing about the program changes. We're not going to talk a lot about what's happening under the hood here. In other words, when I type a command and Python executes that code, what is really happening? What's really happening is those commands are going to something called a Python interpreter, which knows the Python language and knows how to execute that as computer code. That's stuff that happens under the hood at the level of machine code or assembly code. That's for a different class that you guys, if you're a computer science majors, will take down the road. You'll take a computing theory class. You'll take a class where you get under the hood of the interpreter, the compiler that actually creates the executable code. We don't need to care about that. All we need to care about is the interpreter needs to understand what we're saying, and we also need to understand what we're saying. The interpreter needs to understand this, we need to understand that. Now, again, who is this for? If I write the code, I know what the code does, right? I don't need to write a little comment here for every single line to tell me what every single line does. That's probably true. But if you do this for many years, like I have, you will occasionally run into a situation where you got to open up code that you wrote 3 years ago. You think if you open up code that you wrote 3 years ago, you will remember exactly what all the things did and why you did that and why you named this variable this and how this loop works? No, you won't. Trust me, you won't. Then you have to figure it all out again. I have saved myself a lot of work by commenting my code well, so that when I go back and look at it a long time later, I can understand what's going on. Now, is there such a thing as too much commenting? Sure, you don't need to comment every line of your code, right? Sometimes it's obvious what a line of code is. I wouldn't comment print statements in a real code because print this thing already tells you what the line does. In real code, I wouldn't necessarily comment a regular old print statement, but I might comment a statement that's got to explain what a print statement does and why it works in a particular way. Other thing I do is at the beginning of every piece of code, I make a little block of comments that explains what this code is, when I wrote it, again, none of those comments are interpreted by the Python compiler. They're just for me. What are these big long lines? I just think those look cool. I just think it's nice to make a little box with your code in it, with your comments in it, so that you can set that apart. And like I said, I like to use 3 of these: 2, 3, 2, 3, 2, 3. Okay. So over the course of the semester, you will hopefully develop your own commenting style. Maybe you don't like these lines like this. You could do something like this. this, and then a bunch of these little squiggles. Like that, right? Whatever helps you and your eyes separate the comments from the executable code is good. And I should be able to, when I look at your code, understand, even if I print it out so I don't see the pretty green coloring, or even if I paste it into Canvas so the auto coloring goes away, I should be able to easily see what are the comments and what are not. A little weird thing about computer code and conventions, you'll notice when you see printed computer code, it's almost all in the same font, or some font that's very, very similar to this. A font like Courier or Monaco. This font is called a monospaced font. Do people know what that means? The difference between a monospaced font and other fonts? Most fonts nowadays adjust the spacing between letters to match the size of the letter. For example, if I write the word all and the word app, the word app will be wider than the word all because the word P is wider than the letter L. Okay? This is a font that adjusts the spacing of the letters to match the size of the letters. In a monospaced font, all the letters have the same width. So if you type all and app, they're the same width. Okay? Courier is a big one. And that's like looks like an old typewriter. Typewriters were like this. Okay, and a typewriter. Okay, every key is just a little piece of metal with a letter, and it goes bang, bang, bang against the piece of paper. They're all the same width, so that's good for computer programming because if you have, for example, a bunch of print statements, okay, they're always the same width. If you leave a bunch of spaces for your comments, there's a number of spaces. If I change this to a number that's a different width, that doesn't change the size of the space, so keep your code tidier. But if you copy computer code and just paste it into Microsoft Word in Times New Roman, it looks like hell because all your alignment's all screwed up now, right? So just select all your code, change the font to Courier No. I think Monaco is a monospaced font. Courier No is the easiest one. And then your code in a document will look the same as the code look on the screen. That's just a little formatting issue that comes up from time to time. How are we doing on time? It is 12 o'clock. Do I want to do anything else other than did attendance? I did a hello world. I did welcomes. I did comments. I think that is all I want to do. So your homework for tonight is very simple. Go to the Canvas for the course. Click on the link to Code HS. Register for the course on Code HS, and create your own little Hello World program with a print statement that can say hello whatever you want, and a block of comments in the style that you like to comment, just so you can learn your way around the Code HS environment and play around if you want. One of the things we'll look at tomorrow is how forgiving is Python to things like spaces and returns. For example, suppose, well, let me hit run again since I changed it. Get into the habit of running your program every time you make a major change to it. So that way you'll know if you made a mistake. Suppose I put a bunch of spaces in here. And run it. It understands those spaces. Suppose I put a return in here. Doesn't like that, right? What error am I getting? I'm getting the same unterminated string literal. What does that mean? That means Python interprets a return as the end of a statement. So you can't do that. You can't put a return in the middle of a Python statement. What if I wanted hello and then class on the next line? What could I do? Well, I could do this. I do that. That should work, right? I could also do this, I think. Again, this is one of those times where the fact that I know 4 other languages works against me. Ha ha ha. I can also put little secret codes in my print statement called control characters that the interpreter interprets as having some meaning. The \n means new line. So I can tell Tyler, I want to say hello class. Copy that again. Oh, I don't need to copy it. It's just /n. /n, welcome to CSCI 221. Run that. And now it creates a new line every time it sees that little \n.
Save space.
What's that?
They save space.
It does save space, so I don't have to write that in 3 separate lines, right? There are all sorts of little formatting things like that that we can learn over the course of the semester. For now, what's important to know is that breaking a statement in the middle with a return breaks the code, okay? Python understands that the end of that a return is the end of the statement. Not all languages have been like this. If I did this in C, we have no problem at all. Why? Because in C, there's a special character that you put at the end of every freaking statement in the language, and that is a semicolon. In C, there is a special line terminator symbol that says all right, this is the end of the line. The next thing you see is a new statement. Python doesn't have one of those. I have a love-hate relationship with that because I like deciding where the end of the statement is. But I also don't like going through my program and finding 100 missing semicolons, which is what programming in C++ is like. So Python doesn't have a line terminator. The line terminator is hitting return. That's an important thing to know. Okay, so that's just basic output. Tomorrow we'll talk about input, how to get things into our code from the console, and we'll take a little deeper journey into the IDE and CodeHS. Okay, so I don't even think I'm going to write this up as an assignment on Canvas. I will just trust everybody here. Well, maybe since people aren't here, I should. Go to Canvas, go to CodeHS, register, make your own little Hello World program, just so you know how to do that. And then tomorrow we'll start with some more examples. Okay? All right. See you everybody tomorrow.
It's not 10 minutes good for the note that I got.
Yeah. You were only, I had barely started talking, so. Yeah.
Would it be better if I just brought my own computer?
If you want to bring your own computer, you can. It won't, like